Okay, so in this video, our primary objective is going to be evaluating a function at a number, okay? And the next video, we'll do it at an algebraic expression. Okay? But I did want to review what a function is and give a couple of examples before doing that, okay? So examples of functions: height is a function of age, okay? And one way we can think about this in terms of the definition of a function is a rule in which each input has one and only one output, okay? So the input here is age. You know, I can't have, like today, whatever today's date, I can't have two different heights. I can only have one height, all right? Temperature is a function of date. Cost of mailing a package is a function of weight, okay? So notice in this case, the input is age, date, weight, radius, time, okay? The independent value or the output, the dependent value or the output is height, temperature, cost, area, and height, okay? All right, so the height of a projectile is a function of time. So if I throw a ball upwards after 3 seconds, the ball can't have two different heights. It's only gonna have one height at that given point in time, all right? So think about some other examples where you might think represent functions, all right? Now, as we get into higher levels of math, we use letters like F, G, and H, and others. Honestly, you could use any letter in the alphabet to represent functions if you want to, and in many cases you might. We're going to use function notation moving forward, okay? So an example in function notation is f of x, it's read f of x equals x squared, okay? Well, this is a rule. This is the function, okay? And what it means is f is the rule, and what we're going to do is we're going to square the number. Whatever the number is, we're going to square it. So this works for any real number in the set of all real numbers, okay? You could plug in -1 million, and you could find a value, okay? You could plug in +1 million, and you could find a value, okay? So this notation helps us, it gives us a little more latitude, and it makes it a little easier for us to work with. So if I were to plug in 2, I'm just going to square 2 and I get 4. If I want to find the rule of f at the number of -4, then I'm just going to plug in -4 for x, square it, and I get 16. Okay? And if I just plug in a variable, then I get the function I started with if I plug in x. Okay? So some vocabulary here to remember. F of x, remember we're going to read it as f of x, the function of x. Okay? F of x is going to be interchangeable with y as we move forward, okay? But it's a lot more useful to use the function notation, all right? We've got domain, we've got range, independent variable, dependent variable, input and output, okay? Again, you should have heard all these terms before. Now remember, domain, independent variable, and input, they all have a relationship. We usually think of those as the x variable. The range, dependent variable, and output, we usually think of those as y. But if you're dealing with different functions where you're using different variables like height and time, you're going to need to be aware of which of those variables relates to each of these vocab terms, okay? So now, let's do some quick evaluating of functions. So, we've got a function here, f of x equals 3x squared plus x minus 5, okay? And we can think of that as f of blank, whatever x may be, equals 3 times blank squared plus blank minus 5, okay? Again, we can plug in any real number for x and evaluate using order of operations, okay? So real quickly, we're going to go through about 4 examples here. We want to evaluate f of -2 for our given function. So f of -2, notice here in gold, I've kind of showed that we're plugging in -2 where these blank spots were. So everywhere you see an x, 1, 2, 3 places, you're going to plug in -2, okay? Now again, notice this doesn't mean f times -2. This means the function at the value of -2, or the function when we plug in -2 to our trinomial here, okay? So now on the right side, I'm just going to use order of operations to simplify that. This f of -2 is never going to change, all right? So f of -2, we're going to square here, -2. That gives us 3 times 4, minus 2 minus 5. That gives me 12 minus 2 minus 5, which gives me f of 2 equal to +5. Now, This, again, is function notation. What this means is, again, we're going to be graphing pretty soon. When the x value is -2, the y value, or the dependent variable, is going to be 5. So we can say, once we see this, we can say -2, 5 is going to be on the graph of the function. Okay? And again, that's why function notation is more useful. I don't have to say evaluate the equation and find y when x equals -2. I can just say, what is f of -2? And I get 5. And this gives me a point on the graph. Okay? Pause the video, evaluate f of 0, f of 4, and f of 1/2, and then come back and check your work. Okay, let's evaluate f of 0. So we're going to replace x in our given function with 0. So f of 0 is going to be 3 times 0 to the second power plus 0 minus 5. Okay, well, that gives me 3 times 0 plus 0 minus 5, which is going to be -5. Okay, so the point that's going to be on the graph, f of 0 equals -5, means 0, -5 is on the graph of the function. All right, let's evaluate C, f of 4. Again, we've got our given function. We're going to replace x with 4 at each spot. Okay, order of operations, f of 4 equals 3 times 16 plus 4 minus 5, which is going to be 48, plus 4 minus 5, which gives me 47. So the function with a value of 4 for x is going to equal 47. So that means 4 comma 47 is going to be on the graph of the function. All right, last one. Let's plug in 1/2 everywhere we see an x. Okay, a little bit tougher here because we've got fractions to deal with, but that's okay. So f of 1/2 is going to equal. So we're going to square the 1/2. That gives us 1/4. I'm going to get rid of parentheses here and really nothing else to do. So next thing I'm going to do is I'm going to get common denominators for everything. So 3 times 1/4 is 3/4. 1/2 I'm going to convert to 2/4. And -5 I'm going to convert to -20 over 4. So we combine those numerators. 3 plus 2 is 5. -20 is -15. So f of 1/2 is going to be -15 over my common denominator of 4. Okay? So what that means is 1/2 and -15/4 would be an ordered pair on the graph of the function. Okay? So that's how you evaluate function notation. And that's a real quick basic introduction to what a function is. Again, that should all be review, but it's never, there's never too much review, I don't think, when we're talking about functions.